Okay, for this screencast, I'm going to do a root locus. So I'm going to assume that my second order transfer function looks like this. And what I'm going to do is I'm going to say for, so I'm gonna make a for loop. And let's make this a little bit simpler. So I'm going to say kp vec equals np dot, so I need np. So import numpy as np. I'm going to say linspace, what do I want? I'm going to say 0 to 100 and 100, let's say 20 data points. And so I'm going to say for kp in kp vec print kp. And so what I'm going to do this just so you see what happens. So here's kp. So you see that kp is varying from 0 to 100. And then what I'm going to do is I'm going to say the denominator d is going to be 1, 8, and then 15 plus kp, and I'm going to go ahead and print d, so you see, invalid syntax. And so here's the denominator varying, and so then I'm going to say r is np.roots of d. I don't need to put that in an array, it already is. And then I'm going to print r. And so here is r. So it looks like it's originally -5 and 3, and then it as soon as I make kp5, it immediately goes imaginary. So I might need to do more data points, and I'm going to get rid of all these print statements, except for the roots. And so now we can kind of see what's going on. So it's -5, and then they get closer and closer, and they're critically damped, and then boom, it just it blows up. So it doesn't have very much damping. We could probably jack up the damping if we wanted to, and that way we could see. The roots are much farther apart, so they take longer to join up before they split into an oscillatory mode. So basically what I do, when I have plt.figure here, at the end of the day I want to do plt.show, but what I want to do is I want to do plt.plot, and I want to plot the real component and the imaginary component on here. And then I also want to plot, because I have there's two roots, so we should be good. So we should be okay. So how do I get the real component? Let me pause for a second and figure that. Okay, I don't even understand why I even looked that up. It's np.real of r, and then np. I didn't actually look this one up. This is a straight guess. Here's my plot. Oh my gosh, why are there so many figures? Where is my close all? plt.close all. My computer is about to shut down, and this is going to be total failure. Okay, so it looks like it's doing the thing, but it's plotting it in like a million different colors. So let's do color equals blue, and marker equals an asterisk, and that way it's the same every time. And there we go. So there's my root locus, boom, like that. And I'm going to pause this. I'm going to go get my charger, and then we're going to revisit and do some cooler stuff. Okay, so I went a little bit off the deep end on this one. So I found that there's a script called draw now. And so what I'm going to do is go to tools, canopy terminal, and type in pip install draw now. And I've already installed it because I did it while I was off camera. And it should install draw now, and so you can just do from draw now install draw now. And so basically what draw now does is it just like MATLAB, it draws now. The problem is that every time it draws, it clears the figure, and so there's a couple things going on. So I'm gonna delete a lot of what I've done and recreate it, just so you can see what's going on here. np.real r, np.image r. So in order to make draw now work, what you need to do is make a function called plotting script, where you just do your plots. And I'm going to change this back to plot so you can see what happens. And then basically what you do is every time in the loop, in this for loop, you do draw now plotting script. And so I'm going to run that, and what you'll see is it just plots one at a time. And not only that, it plots a line. And so first of all, to get rid of the line, you just do scatter, and then that way it'll just plot dots, but it's not plotting all of them. And so what I really want to do is I want to make a vector of all of the reals. And so what I'm going to do is I'm going to make reals empty vector, images empty vector. And then what I'm going to do is I'm going to say reals dot append, and I'm going to say append the real component of R, and then images dot append np the images of R. And what append does is it takes this value and it appends it to the reals. So reals essentially becomes a vector that's bigger and bigger and bigger and bigger. And then in this plotting script, instead of just plotting one single data point, I'm going to plot the reals, and over here I'm going to plot the images. And then now you actually see that it renders in real time. And so this is a really cool way to animate Locus plots. And it's actually really cool just to animate in general. So there you go. I hope that will help you on your quest for control system dominance. And as always, if you have any questions, post in the comments. And send me an email if you need any help. Good luck.